Hello everyone, thank you for joining us today for HashiTalks Builds. Today, we'll be talking about backward compatibility when developing AWS Provider resources. How can we test for backward compatibility when contributing to the open source AWS Provider? And we'll also cover how to ensure backward compatibility when new features and new arguments are released and we want to support it in the AWS Provider. So I'm Glenn, I'm a cloud architect at AWS, and I've been contributing to the Terraform Provider for a while now, and I find it very fulfilling, and I'm happy to share with you some of the observations I've made when coding for backward compatibility, and hopefully you can apply this to your development and contributions towards the provider as well. So let's dive right in. So this is an overview of what we're covering today. First, we'll run through the basics, how the Terraform Registry relates to what we see in the GitHub repository, as well as the API documentation. Next, we'll go through the background of the specific task, and this task is used as an example of how we introduce a new argument to an existing resource and ensure backward compatibility. We'll talk about some of the challenges faced when coding for this particular task, as well as solutions to these challenges, and how these solutions ensure that there's backward compatibility for the various arguments that are introduced. Next, we'll test for backward compatibility. That involves listing out the various test cases, putting ourselves in the shoes of practitioners to see how they might use the resource, and test for the different use cases. Finally, we'll talk about how we document these changes to ensure that practitioners know what are deprecated arguments and what are the new arguments that they should be using, as well as what are the new arguments that are related to the new feature releases. So let's dive right in. So the first is the Terraform Registry and the provider. So over here, I've taken a screenshot of the EC2 instance resource from the Terraform Registry. We can see that it supports an argument called enclave options. And this is actually defined as a single block in Terraform that supports one argument. So on the right, you can see enclave options over here. And this is defined as a block below that supports the enabled argument that can be set to either true or false. And I've added a link to the registry over here as well. So how does that look like behind the scenes in the repository? So in the Terraform Provider code base, similarly we see enclave options over here. It's defined as a type list with max item of 1 since it's going to be a single block. It supports the enabled argument, and this is a boolean that can be set to either true or false. And again, this is linked over here. You can click on it to see the full definition of the resource in the GitHub repository. So let's also take a look at the AWS API documentation to see how it relates to how the schema was defined over here in the repository. So in the AWS API documentation, similarly, we're looking at the enclave options argument. So for example, this argument has a type of enclave options request. And then let's take a look at that object. So within that object, again, supports enabled, and it can be set to either true or false. And I've linked the documentation here as well. So we can see that this relates to the schema where one enclave option support a single argument. That's what we see in the code schema, and we also see that specified in the registry. So typically the code would follow what we see in the API documentation as closely as possible. So let's go over the background of this particular task where we are going to introduce a new argument to the same resource. So this particular argument comes from this new feature release. So you can see as of April 28, 2023, Amazon EC2 now supports AMD Ceph SMP. So this is the release announcement. I've linked it over here. And let's look at the API reference. So there is a run instances CPU options argument. So within the API of run instances, which creates the EC2 instance, it supports a CPU options argument, and this has a CPU options request object. Within that object, it supports 3 arguments, EMD, Ceph, SMP, that can be set to either enable or disable. And we can see that there's core count and threads per core as well. So these are 3 arguments supported under the CPU options. So this is a bit of the background. We're trying to add this AMD Ceph SMP to the provider for this particular AWS _instance resource. So some of the challenges faced for this particular edition was backward compatibility, and we wanted to ensure that whatever we're adding would not result in unexpected terminations for practitioners. because all these arguments must be specified at create time. As of today, there's no update API for them, so we have to be extra careful when coding this particular new feature. So we can see this is the existing provider schema. It defines CPU core count and CPU threads per core outside of a CPU options block. So this deviates slightly from the usual convention where we follow the AWS API documentation as closely as possible. So these are the two arguments that potentially should be deprecated and moved over to the CPU options block. So let's look at solution number one that does exactly that. So solution number one, we introduce the CPU options block. Similar to the enclave options block, we define it as a type list with max item of 1. Within that block, we support the core count and the threads per core argument as seen from the AWS API documentation. And over here, we specify a conflicts with, and we conflict with the older arguments of CPU underscore core count and CPU underscore threads underscore per core. So we conflict with this so that practitioners can only use either one of the old or the new arguments that we've just introduced. So next, let's go back to the previous arguments, and now since we have introduced new arguments, we want to deprecate these old arguments. So you can see we've introduced a deprecation notice over here to prompt practitioners to use the CPU options block instead. And similarly, we also specify the conflicts with. So practitioners should only be either using the newer arguments, and they should be using the newer arguments, or using the older arguments. They should not use both at the same time, and we will throw an error if we encounter such a case. So that is the solution to challenge number one. So challenge number two. So challenge number two is allowing argument specification without terminating EC2 instances. So what do I mean by that? So in this screenshot here, we can see on the left, maybe a practitioner has defined a CPU options block without specifying AMD Ceph SMP. So that value, it's now empty. And then after that, they decided to apply, and now they explicitly specify AMD Ceph SMP to disable. Now for some background, by default for EC2 instances, this argument is set to disable. So if as a practitioner, if I set the argument explicitly to disable after in the second apply, when the first apply I haven't specified it, I wouldn't expect the EC2 instance to be recreated. I would expect no changes detected. So back to our CPU options block, we can see that we also have a AMD Ceph SMP supported argument over here. And here we introduce a diff suppress function. And what this does is it first checks whether the ID is not equal to an empty string. So what this means is checking whether the EC2 instance is a newly created instance or an existing one. So we want to check for an existing EC2 instance. So next, it also checks what are the old values for the AMD Ceph SMP and the new value. If the old value is an empty string, meaning that the practitioner has not specified AMD Ceph SMP, and then suddenly in the new value specified it as disabled, we want to suppress the diffs, hence we return a value of true. In other scenarios, for example, if practitioners did not specify AMD Ceph SMP, and then suddenly specified it but set it to enable, we will want it to not suppress the diff. We want the diff to actually happen, which should then force a new EC2 instance to be created, which terminates the old one and creates a new one. Hence, you can see that there's a false new over here because there is no update API as of today. So with all the backward compatible changes in place, let's look at how can we test and validate our changes are correct. So the first step, let's look at the CPU options block. So for the CPU options block, we want to test that the deprecated arguments still work, because usually deprecations don't happen within the minor version. They happen in the transition to the next major version. And then we also want to test for you practitioners who are now on the deprecated arguments, can they migrate over to the new arguments safely without having EC2 instance terminations. So you can see the test cases listed out over here. First one, we want to test that the existing deprecated arguments still work. The second test case, we want to test that the new CPU options block still works with the core count and threads per core, which are the newly introduced arguments, to replace the deprecated arguments. The third one is interesting, where we want to transition from the deprecated arguments to the new CPU options block, and we will expect no EC2 instance recreation. Next, we want to test a bit more robustly, where we test the CPU options block without specifying core count and threads per core. This means that it'll be its default values. And then we expect no recreation when now practitioners specify the core count and threads per core with the default values because nothing has changed. We want to test that scenario as well. And finally, we want to test the new CPU options block with core count and threads per core only without AMD Ceph SMP to ensure that it still works as expected. So let's zoom in on the third test case over here. So in the third test case, an example you can see is on the left. So on the left, the practitioner is using the deprecated arguments, which is the CPU core count and CPU threads per core, and it set it to values of 2 for both. On the right, now the practitioner decides to migrate over to the newly introduced block, the CPU options block. So they define the block and they specify core count and threads per core also with values of 2. In this case, they would not expect any EC2 terminations. So when we migrate there, again, in the codified test case, we would test that the EC2 instance is not recreated, and we do that by checking its ID. Its ID shouldn't change across multiple Terraform applies in this particular situation. So this is just one of the interesting test cases for testing of transitions between deprecated arguments to new arguments. Next, let's go over the test scenarios for the new AMD Ceph SMP argument that is part of the CPU options block. So the first two test cases are rather straightforward. We just test what happens when it's enabled at create time and then updated to disabled. In this case, we expect recreation because as of today, there's no update API for AMD Ceph SMP. It must be specified at create time. So similarly, we test the other way, where AMD Ceph SMP is set to disable and then updated to enable. Again, we expect recreation. Next, we want to test CPU options with all three arguments now: AMD Ceph SMP, core count, and threads per core. That should work. Next, we want to test practitioners without a CPU options block and then update it in the next Terraform apply. They have an update where they introduce a CPU options block with AMD Ceph SMP as enabled. Now, by default, AMD Ceph SMP is disabled on the first Terraform apply. So in the next one, when they explicitly specify it to enable, we expect recreation. Now, in the next test case, this is the interesting one. When on the first apply, practitioners specify the resource without the CPU options block. And now in the second apply, they specify the CPU options block with AMD Ceph SMP as disabled. In this case, since in the first apply, AMD Ceph SMP is by default disabled, we will expect no recreation. So let's see how these test cases can be codified. So the provider provides a very convenient function where we can just specify a command like the following. And this then starts the various test cases, as you can see over here. So we'll wait until all the test cases pass, as you can see, and then typically we will copy and paste this in the pull request that we make against the repository. So that brings our testing to a close. And now the next very important part still is documentation. So we want to inform practitioners who read the documentation at the Terraform registry on what arguments have been deprecated, what are some gotchas that they may have to take note of, as well as we want to introduce the new arguments to practitioners as well. So over here, we start with the basics. We want to introduce the new arguments. So here we introduce the new CPU options block, and we state that it supports the following three arguments as what we've seen in the API documentation: AMD Ceph SMP with the enabled and disabled valid values. We can specify core count, and we can specify threads per core. Next, we want to also set a warning that modifying any of these three arguments would cause a resource to be destroyed and recreated. So that is for practitioners who might want to update it so that they can read the documentation and are aware that any updates to these three arguments would cause a new EC2 instance to be recreated. So we can see also for the old arguments, we also want to set a deprecation notice. So for the CPU core count and the CPU threads per core, we specified it as deprecated, and we recommend that practitioners use the new CPU options argument instead. So with that, our documentation is completed, and we have seen how we can code in a backward compatible manner. We've seen how we can test those backward compatible changes, and finally document those changes. And that brings me to the end of Hashi Talks. Thank you very much for taking the time to attend, and let me know if there are any questions. Thank you. Bye-bye.